Welcome to the second video of the module 2. In this video, I am going to explain the problems based on the introduction. Solve 4d power 4 minus 4d cube minus 23d square plus 12d plus 36 of y equal to 0. By replacing d with the m, we get 4m power 4 minus 4m cube minus 23m square plus 12m plus 36 equals to 0. If m is equal to 2, by replacing d with m, the equation will be 4m power 4 minus 4m cube minus 23m square plus 12m plus 36 equals to 0. By inspection, m is equal to 2 is one of the root. Then, by the synthetic division, we reduce this equation to 4m cube plus 4m square minus 15m minus 18 equals to 0. Again, if we put m is equal to 2, that is one of the root. Once again, we apply the synthetic division, which reduces to 4m square plus 12m plus 9. That gives us m is equal to minus 3 by 2 and minus 3 by 2. Hence, the roots are equals to 2, 2, minus 3 by 2 and minus 3 by 2. And the solution will be c1 plus c2x e power 2x plus c3 plus c4x e power minus 3 by 2x. That is the general solution. Next question. Solve d power 4 minus 5d square plus 4 of y equals to 0. The auxiliary equation is given by m power 4 minus 5m square plus 4 is equal to 0. That is m squared minus 1 into m squared minus 4 is equal to 1. Hence, the roots are 1 minus 1, 2 minus 2. Therefore, the general solution is given by c1 e power x plus c2 e power minus x plus c3 e power 2x and c4 e power minus 2x. That's the general solution. Next question. Solve d power 4y by dt power 4 plus 8d square y by dt square plus 16y is equal to 0. That is, the auxiliary equation will be m power 4 plus 8m square plus 16 is equal to 0. Thereby, the roots of this equation will be plus or minus 2i and plus or minus 2i. That is repeated imaginary roots. Hence, the solution is given by c1 plus c2t into cos 2t plus c3 plus c4t into sin 2t. That is the general solution. Next example. D power 4 plus 64 of y is equal to 0. So, we know that a square plus b square is equal to a plus b whole square minus 2ab. We have m square the whole square plus 8 square. That is m square plus 8 the whole square minus 16m square. This on simplification, we get m square minus 4m plus 8 equals to 0 and m square plus 4m plus 8 equals to 0, which on solving we get the roots are 2 plus or minus 2i and minus 2 plus or minus 2i. That's the complex roots. Hence, the general solution is given by y is equal to e to the power of 2x into c1 cos 2x plus c2 sin 2x plus e to the power of minus 2x into c3 cos 2x plus c4 sin 2x. Next question. D power 4x by dt power 4 minus 2d cube x by dt cube plus d square x by dt square is equal to 0. This on reducing the auxiliary equation m power 4 minus 2m cube plus m square is equal to 0. Taking the m square common, we get m square minus 2m plus 1 whose roots are 0, 0 and 1, 1. Therefore, x is equal to c1 plus c2t plus c3 plus c4t of e power t. That's the general solution. Next problem. Solve 4d power 4 minus 8d cube minus 7d square plus 11d plus 6y is equal to 0. This on solving, minus 1 is the root by inspection. By synthetic division, if we apply, it reduces to a cubic equation, that is 4m cube minus 12m square plus 5m plus 6 equals to 0. Again, by inspection, m is equal to 2 is one of the root. Therefore, it reduces to 4m square minus 4m minus 3 equals to 0, and the roots of that equation will be minus half and 3 by 2. Hence, the roots are minus 1, 2, minus half and 3 by 2. Therefore, the general solution is C1 e to the power of minus x, C2 e power 2x, C3 e power minus x by 2 and C4 e power 3x by 2 is the general solution. Next question. D power 5 minus d power 4 minus d plus 1. Taking m power 4, I am writing it in the auxiliary equation form, and taking m power 4 out from the first two terms, we get m minus 1 common. Again m minus 1 if we take common, we get m minus 1 into m power 4 minus 1, which can be further written as m square minus 1 into m square plus 1, that is equals to 0. Or further splitting that and getting the roots as 1, 1, minus 1 plus or minus I. Thereby the solution is C1 plus C2x of e power x plus C3 e power minus x plus C4 cos x plus C5 sin x. That's the general solution. Next question. D power 4 x by dt power 4 is m power 4x. Show that x is equal to C1 cos mt plus C2 sin mt plus C3 cos h mt plus C4 sin h mt. We have d power 4 minus m power 4 x is equal to 0. So the auxiliary equation will be d power 4 minus m power 4 and p square plus m square and p square minus m square. So p will be plus or minus mi, p will be plus or minus m. Therefore, this x will be equal to C1 cos mt plus C2 sin mt plus C3 e to the power of mt and C4 e to the power of minus mt. Consider the desired expression, and this can be written as cos h mt and sin h mt. So we conclude that C3 and C4 are also arbitrary constants. Thank you.